Good evening. Thank you for watching. Once again, I'm playing around with the 74HC595 shift register, which is a serial to parallel shift register. In my previous two videos, which do much the same thing, they both programs just spit out a fixed constant onto the shift register, and that's it. It just displays a number. I am bouncing around from topic to topic here, but when I was experimenting with my PIC16F684 chip, which is a different chip, and I have a playlist for that, when I was playing around with the PIC10F200 and using the shift register, the very same one, the 74HC595, I created a counter. You can see it in action here. It's just counting the bits up to 255 in decimal. So I thought, okay, maybe I'll do something different than creating a counter. What if I had a single LED rotate across the shift register? Now, when using this shift register, you can clock in one serial input data bit one at a time. You can send a high and then clock it, and then send a low and clock it. And then finally, when you've sent 8 bits, you can hit L clock. Well, anyway, the thing is, you can actually watch your bits get clocked from the most significant bit down to the least significant bit if you clock them in one at a time. And I'm going into detail in explaining that because that is not what I'm doing. Instead, in my code, I am using the rotate right through carry. Visually, it looks very similar to just clocking in a bit at a time on a shift register. That's actually not what I'm doing. This code is set up to take an entire byte, test each bit, and then send out the whole byte. Alright, so forgive me, this video you're watching here isn't the most well constructed, covering a lot of different ideas. In a way, it's a memorandum for myself because I'm learning as I go. I'm no expert. If you appreciate this type of video, then thanks. We're learning together. If you want to watch a professional, I'm not necessarily the guy. Anyway, just a follow-up comment if you've been watching these videos in order. So I did this optimization code, and without going into detail, I tried further modifying this optimized code. And without going into technical detail, I was getting some buggy code in this optimized code in this part 10 video. It wasn't really doing what I was intending to on the shift register. That's for lack of a really complicated explanation. I'm not sure why this particular code wasn't working very well either. I just know it isn't working that well. So if you're copying this and trying this, yeah, maybe it's not going to work for you. And then I was trying to make some adjustments to it, having a lot of trouble. So I went back to my part 9 video before I optimized my code. And, well, I'll click on that. So here it is here. And then I pasted the code in the pinned comment. And now I've just copied this and pasted it into MPLab. And I'm just trying to get it to do something different than counting from 0 to 255. I thought, well, maybe I'll have a single least significant bit be high, and then I'll rotate that right and have it flash across the shift register, kind of in a running lights type of presentation. So now I'll just cover some of the changes I made from that part 9 video where I'm first experimenting with this shift register. So in this initialization block here, in this part of the code here, I initialized the C1 memory location, which I was going to specify as a counter, but I'm not doing that anymore, so maybe I should change the comment. Specify file to experiment with. So that's what C1 was created for. So I moved all zeros into C1. I suppose I could have just done clear F. Here's what I've found. This is a memory location that I'm experimenting with. When I move all zeros, or if I clear F it, when I move all zeros into this file location, it should present all zeros on the shift register. Nothing should be visible. And what I've done in this program, as compared to my previous code, I included this rotate right through carry. Now the funny thing is I'm still getting a bit that is rotating from one higher than the most significant bit down to the least significant bit, streaming across the shift register. So why is that the case if I've sent all zeros, I've cleared F'd the C1 location? Well, what I think is happening is that there's a carry bit when you use this instruction. Okay, so I searched on the internet here for an explanation of the RRF instruction. And I will read. In PIC programming, the instruction RRF, in my case C1 file location, maybe I shouldn't have included that, is a bitwise operation used to rotate the bits in a file register to the right. Let's break down the components of this instruction. Instruction breakdown, RRF. This stands for rotate right through carry. It means that the bits in the specified register are rotated one position to the right. The least significant bit that is shifted out is moved into the carry bit, and the previous carry bit is moved into the most significant bit of the register. Okay. So originally I tried writing the code like this with a 1 here, and it did work, but 1 bit on the output on the shift register, it wasn't 1 bit that was streaming across, it was 2 bits side by side. So it led me to believe that this 1 bit along with the carry bit were kind of paired together and streaming across. So ultimately I chose to put all zeros there, and I'm like, well, that's the same thing as clear F. So that's why I have done a clear F here. And I'll show the video. So I don't exactly know why things are working that way. I think it has to do with the carry bit being rotated right with that RRF command, but I'm not even sure. So I'll leave this video open-ended, and if you have an idea, please comment below. And if I learn what's going on, I'll maybe leave a comment as well and make an update video. Okay, thanks for watching.